Welcome to our channel Learning Math. In this video, we're going to learn about shaded areas. Let's start together. As you see, we have here a triangle of base 8 cm and height 5 cm. So the area of this triangle is base times height over 2. We say it's 8 cm times 5 cm over 2. We can simplify 8 is 2 times 4. We can simplify 2 by 2. What remains for us? 4 centimeter times 5 centimeter. 4 times 5, 20 centimeter times centimeter squared. What about the square? As you see, we have a square of side 8 cm. So the area of this square is side times side or side square. So it's 8 cm times 8 cm gives us 64 cm. Well, let's think about it. If a child wants to color a house, how to do it? Shouldn't he color the square and the triangle together? So the shaded area here is for both the square and the triangle. So here we need to add them. In this case, we say that the shaded area is equal to the area of the triangle plus the area of the square. Now we add them to get 20 centimeter square plus 64 centimeter square, which is 84 centimeter square. Another example. As you see here, we have a square and a rectangle. The square has a height 4 meter and the rectangle has also other measures, length and width. We're going to see them. Now let's start by the area of the square, which is side square. So it's side times side. 4 meter times 4 meter gives us 16 meter square. Here is a rectangle of length 1.8 meter and width 1.1 meter. Isn't the area of this rectangle length times width? So we should write it 1.8 meter times 1.1 meter. That gives us 1.98 meter. Well, let's think about it. If we have a wall and we want to paint this wall without a door having the same measures as this rectangle, shouldn't we paint all of this wall without the door? So the shaded area in this case will be the area of the square, which is the wall, minus without the area of the rectangle, which is here 1.98 centimeter square. So we just subtract them. 16 centimeter square minus 1.98 centimeter square gives us 14.02 meter square. Another example. As you see here, we have a disc and a square. Well, what are their dimensions? The disc has a radius 3 centimeter. Isn't the area of the disc pi r square? So it's pi times r times r. It's 3.14 times 3 centimeter times 3 centimeter, which is 9. Here 3 times 3, 9 centimeter times centimeter square. We multiply them by 3.14 to get 28.26 centimeter square. This was the area of the given disc. What about the square? It has a side 4.5 centimeter. Shouldn't its area be side square? So it's side times side. 4.5 centimeter times 4.5 centimeter gives us 20.25 centimeter square. Well, if we cut out from this disc a square of same dimensions, what will happen? Shouldn't here the shaded area be equal to the area of the disc minus the cut area, which is that of the square? So we can say that the shaded area is the area of the disc minus the area of the square. So it's 28.26 centimeter square minus 20.25 centimeter square. We just subtract them to get 8.01 centimeter square. Here we're going to talk about the parallelogram. What's the area of the parallelogram? If you know something, the parallelogram is formed of two triangles. The area of each triangle is base times height over 2. So we can say that the area of the parallelogram is the sum of the areas of these two triangles. So it's base times height over 2 plus base times height over 2 gives us base times height. So the area of a parallelogram is base times height. Now here, as you see, we have a square. We have picked up from this square 4 parts of a circle. Look at them, please. Aren't the four parts together forming a disk? Well, let's see how to solve them. The radius of this disk, isn't it 3 centimeters? So what should be its area? We have here four parts. They all together form a disk having an area pi r square. The radius is 3 centimeters. So it's pi times 3 centimeters times 3 centimeters gives us 28.26 centimeters square. Well, this was the area of the disk that is picked up out of the square. Now what is the area of the given square? We have the distance between them here is 4 centimeters. Now shouldn't the side of this square be equal to the sum of all of them? 3 centimeters plus 4 centimeters plus 3 centimeters gives us 10 centimeters. Here we can say that the area of the square, the whole square, was side square, which is 10 times 10 sure centimeter gives us 100 centimeters square. If it was all filled before picking up the four parts of this circle. Now what about the shaded area right now in this figure? Can't we say that it's the area of the whole square minus the area of the disk? So it's 100 centimeters square minus 28.26 centimeters square gives us 71.74 centimeters square. Here is another example. As you see, we have two semi-discs, one of diameter 16 cm, the other of diameter 8 cm. Well, first of all, you know that the radius of the disc is half its diameter. So for the first disc, the radius is 16 cm over 2 gives us 8 cm. For the second one, the radius is 8 cm over 2 gives us 4 cm. What about the areas of these two semi-discs? The first one, you know that the area of a whole disk is pi r square. The semi-disk, isn't it half of a disk? So it's half pi r square. So we can say it's half times pi, which is 3.14, times r square, which is r times r, here 8 cm times 8 cm. If you know something, we can simplify 8 by 2, we have times. 8, isn't it 4 times 2? Now we can cross 2 by 2. What remains for us? 3.14. We copy it. Here 8 times 4 gives us 32 centimeter times centimeter is centimeter square. Well, what remains for us? 3.14 times 32 gives us 100.48 centimeter square. By the same method, we calculate the area of the other semi-disc, which is 25.12 centimeter square. Now look at the figure. We have just picked up from the first semi-disc the other semi-disc. We are cutting it, so we should subtract. Then the shaded area in this case is the area of the greater disc minus the area of the smaller semi-disc. So it's A1 minus A2, 100.48 centimeter square minus 25.12 centimeter square. Well, now we're going to take a little information about transforming units of area. If we want to transform 2 meter square plus 3 decameter square into meter square, how to solve that? As you see, the first one is in meter square, so we just copy it the same. Here plus 3 decameter square. How to transform from decameter square to meter square? Sure, as you see here, we have from the greater to the smaller. When we transform, we have times. From the smaller to the greater, when we transform, we should have divided by. Each space contains 10 power 2. If we multiply or divide, each one has 10 power 2. Let's start together. 3, we copy it. It's also 3.0. We need it to move the point right now. From decameter square to meter square, from the greater to the smaller, it's times. Times what? One space, so 10 power 2. Directly. We can write it times 10 power 2. Now we write directly the new unit. After multiplying it, we shouldn't write the previous one. We write it directly. Meter square. Now we just move the points. As you see, times 10 power 2, we move the point by 2 digits. Here 2 meter square, we copy it the same. Here we move the point by 2 digits towards the right because we are multiplying. So it's 1, 2. We fill the empty space by 0 to get it 300 meters square. Now we have the same units, so we can add them. An important note. If I have 2 red pens and 3 green pens, can I say that I have 5 green pens or 5 red pens? Sure not. When we have different units, we can never add them. We should transform them into the same unit. Another example, 0.8 decimeter square plus 72,438 millimeter square plus 95.5 centimeter square. We're going to transform all of them into centimeter square. Let's see for the first one, from decimeter square to centimeter square. First, we copy the number we are having, 0.8. From decimeter square to centimeter square, it's times 10 power 2. So we can write it as 0.8 times 10 power 2 centimeter square. Sure, we write the new unit, not the previous one. When we multiplied it, we have just transformed it into centimeter square. Now what about the second one? From millimeter square to centimeter square. How to solve it? Sure, we have divided it from the smaller to the greater. Divided by what? Here one space contains 10 power 2, so it's divided by 10 power 2. Sure, we write the new unit, which is centimeter square. Now the third one is in centimeter square. We just copy it the same. How to solve right now? Here we have times, we move the point to the right. How many digits? Power 2, we move it by 2 digits. So here 8, and we fill this empty space by 0 to get 80 centimeters square. What about the second one? Divided by. How to move the point? When we have divided by, we move it to the left. The same as the sense of the arrows here. For divided by, we move the point to the left. 4 times, we move the point to the right. Here the same procedure. So we should move the point to the left by 2 digits, 1, 2. By 2 digits, we have 10 power 2. Where should be the point right now? Between 4 and 3. So it's 724.38 centimeters square. Now we just copy the third one. The same is in centimeters square. Now we have all of them in centimeters square, so we can add them. Thank you for following. If you enjoyed this video, please like, share, and subscribe.